Hello student friends and welcome to all of you. In these lectures we are start to discussions the bar magnets, but I will give one of the hint for these topics. When we are starting discussions of these topics, the magnetism, we are discuss the comparison and we are revise the same theory of when we are discussed in the previous topics, that is the topic number 10 इलेक्ट्रोस्टॅटिक. वेन वी आर 10 और 9 इलेक्ट्रोस्टॅटिक्स आणि ह्या टॉपिक मॅग्नेटिझम या दोन्हीचा टॉपिकचा कंपॅरिझन करून आपण स्टडी करणार आहे. तर एका टाईममध्ये दोन टॉपिकचा आपल्याला स्टडी करण्याचं एक संधी या ठिकाणी आहे, मॅग्नेटिझम ॲज वेल ॲज इलेक्ट्रोस्टॅटिक्स. देन इन दिस लेक्चर्स वी आर डिस्कस बार मॅग्नेट. तर प्रिव्हियस लेक्चरमध्ये आपण या ठिकाणी काही थोडंसं डायग्राम काढलेला होता मॅग्नेटिक लाइन्स ऑफ फोर्सेस डिस्कशन करण्यासाठी. कन्सिडर दिस इज ए बार मॅग्नेट अँड बार मॅग्नेट इज सेड टू बी हॅव द पोल स्ट्रेंथ. ए बार मॅग्नेट इज सेड टू बी बार magnet is said to be which have some magnetic strength, which have the magnetic pole strength is pole strength is plus qm and minus qm at north and south poles, at north and south poles respectively. North and south pole, that is pole strength, which have the pole strength of the plus qm at a north pole and minus qm at a south poles respectively. We are start to discussion some different points one by one, and it is a separated length of the magnet. The pole separated some length, the length between north pole to the south pole is 2L, and separated, the poles are separated with some distance, separated with distance is 2L, separated with the distance is 2L. The bar magnet has a two poles, that is north poles and south pole. This is the basic information about the bar magnet, and in the previous lectures we are discuss the magnetic lines of forces. They are like this, and they are also formed in inside, they are form a complete closed path. ओके, प्रिव्हियस लेक्चरमध्ये आपण काही काढलेलं होतं, पण थोडंसं डायग्राम किचकिट होऊ नये म्हणून मी आतमध्ये काढलेला नव्हता. तर ते आतमध्ये देखील इलेक्ट्रिक लाईन्स ऑफ फोर्सेस असतात. देन इट इज सेपरेटेड विथ सम लेंथ 2L. देन ए बार मॅग्नेट हॅज ए टू पोल्स विच इज इक्वल अँड अपोजिट पोल स्ट्रेंथ. बार मॅग्नेट हॅज two poles which has equal and opposite pole strength. Opposite pole strength, which is equal and opposite pole strength, that is, and this equal and opposite pole strength is called magnetic dipole, is called dipoles. डाय म्हणजे दोन आणि पोल्स म्हणजे टू डिफरंट पोल्स, दॅट इज नॉर्थ अँड साऊथ पोल्स. अँड द मॅग्नेटिक डायपोल मुवमेंट्स, इन इलेक्ट्रिक डायपोल मुवमेंट्स आपण अशा पद्धतीनं लिहिलेलं होतं, इलेक्ट्रिक डायपोल मुवमेंट दॅट इज P. In the previous, this is magnetic dipole moments. Electric dipole moments P is equal to 2L into Q. Q it is the charges and 2L it is the length between the two different charges and positive and negative charges. But magnetic dipole moments M is equal to as same here. This is same, and this is the Qm plus and minus. Then I will be right here. This is, what is this? The magnetic, it is said to be the magnetic poles, that is plus Q and minus Q. It is a south and north pole strengths of this, and this is the magnetic dipole moments. Then the 2L is a, these are vectors and 2L is also vectors, is vector. We can measure, this is south to north, we measure 2L is vector, we are measure south to north, south to north. Then SI units of the strength or magnetic strength, SI unit of magnetic strength or magnetic pole strength is, the SI unit of strength is ampere meters, and SI units of magnetic dipole moments is ampere meter square, ampere meter square. Then let's discussion some points about the magnetic dipole moment, some terms about the magnetic bar magnets. Then in the electrostatics, we are take the two charges, that is a plus Q and minus Q here, and the line joining between them, and consider one of the center, this is C in the electrostatic topics. But this topic is a different, terms are same when we are discuss electric dipole as well as magnetic dipoles. First terms is axis. In the electrostatics, we are said a line will be passing through the both charges. This is called as axis of the dipoles. And in these lectures, in the magnets, the line passing through the both poles, the line passing through both the poles is called axis, Then I will be drawn here what are the actual meaning of axis. A line, consider they are passing through the line passing through the both poles, या दोन्ही पोल मधून लाइन पासिंग होणार एक आणि एकच लाइन असू शकतं. दिस इज द axis. And let's start some different terms. We are discuss these terms in the electrostatic topics, that is equators. The line passing through the center of the magnet and perpendicular to the axis is called equators. The line passing through center and perpendicular, this is the symbol for the perpendicular, and perpendicular to the axis. Axis is the line passing through both poles. To the axis is called equators. Consider this is the 2L, the length between the north to south poles, and the center, exact center, and distance from the center to north pole is L, distance from the center to south pole is L, and the line passing through, the line I will be drawn for by the different colors, that is equators. The line passing through the center of the magnet and perpendicular to the axis. Axis is a horizontal. I will be drawn a perpendicular of the axis, that is vertical line exactly 90 degree, the angle between the equators and axis, and they are passing through the center. This is the equators. This is called as equators. The line which can be passing through the center of the bar magnet and perpendicular to the axis is called as equators. It's called as equators. A plane containing all equators, as a plane, the plane containing all equators is called as equatorial plane. म्हणजे plane कसे असणार आहे? It is a plane is perpendicular to the board. बोर्डला perpendicular एक असा planes आहे. Consider one of the notebooks or anything. It is like this, and this is the plane containing all equators. Containing all equators is called equatorial plane. Equatorial plane. And this is the about what are the axes, equators, equatorial plane, and one of the locus and the point of equators. A locus point on the equators is exactly equal to the length, is exactly equidistant from the center, which can be make a circle. That is equidistant from the center, which can be make one of the circle. And consider the center of the magnet is one of the center of that circles. Magnetic length, this is the next terms, magnetic length. The magnetic length is a length between or distance between two poles. The distance between two poles is called as a magnetic length. This is a 2L, and how can I find the magnetic length? Is a 2L is equal to 2L is equal to the find the magnetic length. The magnetic length, it is a distance from two different poles or the distance of the bar magnet. This is 5/6 into geometric or geographic line or geographic length. This is the formula for finding of the magnetic length. This is the all about some informations about the bar magnet. What are the bar magnet? Axis of the bar magnet, equators, equatorial planes, and this is the magnetic length. The bar magnet has a two poles to different poles having the strength plus qm and minus qm, that is the north and south pole respectively. North pole ला जे काही त्याची pole strength असणार आहे, that is a plus qm, at the south pole that is a minus qm. It is separated with the length. This is 2L. This is also called as a magnetic length. Then a bar magnet has a two poles which has equal and opposite pole strength, which has equal and opposite pole strength. This is the negative and positive sign shows the direction, that is opposite, and qm, it is a magnitude, that is equal and opposite pole strength is called as a dipole. Which have one of the magnet which have the two different pole strength, they are equal and opposite, ते दोन असल्या कारणाने त्याला म्हटलं जातं dipoles. Then it is the magnetic dipole moments. The formula for the magnetic dipole moments is a 2LQM. Strength In the electrostatics, when we find the electric dipole moments, electric dipole moments, that is P is equal to 2Lq, maybe plus Q or minus Q. In here, maybe plus Qm or minus Qm. The M is shows the magnets, and Q, it is one of the considering part, that is charge or strength. Qm is a strength. Then a magnetic dipole moments is the product of the pole strength and magnetic length. Then 2L is a vector, there's south to north. Then SI units of the strength is ampere meter, and SI units of magnetic dipole is ampere meter square. Let's start discussions. Now I will be comparison between the magnetism or electrostatic or magnetic dipole moments and electric dipole moments. Axis, the both are same. When a line passing through the both poles, this is called as magnetic axis in the form of magnetic dipole moment, magnetic dipoles. Then a line passing through the both charges, positive and negative charges, this is called as axis of the electric dipoles. Then the equators are same. A line passing through the center of the bar magnet, the center, or the line passing through the center when they are placed in some distance, that is positive and negative charge in the electrostatics. Then perpendicular to the axis, this is the equators. Then a plane containing all equators, this is the perpendicular plane. The plane containing all equators is called as equatorial planes, and magnetic length is a 2L. It is a distance from the south pole to the north pole, distance between the two poles, and this is the formula for the calculating of magnetic length. Then now we are solving one of the smallest derivations for the electric and magnetic field. This is all about some informations about the bar magnets. When we are just discussions about the comparison between the electrostatics and magnetism, at the same time we are complete the study of two different topics. And when we are discussing the optics as well as sound, then we are discuss the two different topics at the same times. Then let's start. Consider CDR, it is a consider smallest. Consider one of the bar magnet of a dipole length. Consider a bar magnet. Consider a bar magnet of a dipole length, is 2L. This is same magnets, for we are solving the electrical as well as magnetic field. Then the M bar is magnetic dipole moment. Magnetic dipole moment for considering bar magnets, for considering of bar magnet. We find the magnetic field at a point P. एक पॉइंट कंसिडर करायचं या ठिकाणी. वी फाइंड ए मॅग्नेटिक फील्ड ॲट ए पॉइंट P. या ठिकाणी देखील एक पॉइंट आहे आणि या ठिकाणी देखील एक पॉइंट आहे, आणि आपण या दोन डिफरंट, एक पॉइंट आहे ॲक्सिसवर, देन वी फाइंड द ॲक्झियल मॅग्नेटिक फील्ड. ए पॉइंट ॲट ए इक्वेटोरियलवर एक पॉइंट आहे आणि त्या ठिकाणी आपण इक्वेटोरियल मॅग्नेटिक फील्ड फाइंड आउट करायचं आहे. देन ए पॉइंट consider a point P. Consider we find a magnetic field at a point P. Consider a point P and we find magnetic field as well as we consider electric field at same point, P. Then the distance from the center and point P, the distance R from point P to center of magnet, consider this is the center O, या ठिकाणी O सेंटर आहे कन्सिडर केलं आहे आणि ही जी काही डिस्टन्स आहे दिस इज R and this is also R. OP is a distance R. We know that the distance ON is equal to OS or L. The O is exactly center and the distance from the distance of between two poles is a 2L, then they are divided in a equal parts, that is L, and this is a perpendicular to each others. The both are perpendicular. We use Pythagoras theorem to find the distance of this. Okay, oh sorry, the distance of this. Then how can I calculate the Pythagoras theorems? Then the NP or SP, the distance NP or SP is equal to under root the Pythagoras, the square of hypothesis is equal to, okay, then this is the R square plus L square, this is the R square and L square. They are perpendicular to each other, that makes 90 degrees. This is all about it. Then we know that we can find the length between them, and let's start. We know that in the electric field, the electric dipole moments is a P is equal to 2Q L. We are just writing here. Then in electric field, we are start to discuss the electric field at a axis, electric field at a point P. When they are placed in axis, this is equal to 1 upon 4 pi epsilon 0, it is a constant, and this is equal to 2p divided by r cube. Then R is much more greater than L. R is much more greater than L. Then electric at a equatorial plane, electric field at a equatorial point, that is 1 upon 4 pi epsilon 0 P divided by R cube. When they are same conditions, R is much more greater than this. As like this is all about the electric field, and we are find the magnetic field. Magnetic field. Our same conditions are applied, but we are just changes. A constant मध्ये थोडासा चेंज आपल्याला या ठिकाणी करावा लागणार आहे. तर कॉन्स्टंट मध्ये काय चेंज असणार आहे, 1 upon epsilon 0 mu 0 is equal to 1 upon epsilon 0. हे इक्वेशन्स, हे व्हॅल्यूज when we are converted electric field to magnetic field करत असताना हे इक्वेशन्स आपल्याला यूज करावे लागणार आहे, किंवा हे व्हॅल्यूज आपण त्या ठिकाणी यूज करावे लागणार आहे. देन we are just right, this is the electric dipole moments, this is R same for both, and 4 pi is a constant and 1 upon epsilon 0 is a mu 0. I will be right, and let's find the magnetic field at a axis. Axial magnetic field. Magnetic field shows letter B. We are just discussed in the previous lecture. Then a plus mu 0 divided by 4 pi. Okay. Then this equation will be used here. 1 upon epsilon 0 is mu 0 into, this is for 2m. M is the magnetic dipole moments, RQ. R is much more greater than L. Then for the equatorials, this is minus mu 0 upon 4 pi m r cube. R is much more greater than L. ठीक आहे. दिस इज ऑल अबाउट, फक्त दोन्हीचं कंपॅरिझन केलेलं आहे आणि ज्या ज्या ठिकाणी जे जे व्हॅल्यूज आहेत ते व्हॅल्यू त्या ठिकाणी केलं. इलेक्ट्रिक फील्ड जागी मॅग्नेटिक फील्ड यूज केलेलं आहे, ॲक्झियल जागी ॲक्झियल्स, त्याचबरोबर इलेक्ट्रिक डायपोल मुवमेंट जागी त्या ठिकाणी मॅग्नेटिक डायपोल मुवमेंट यूज केलं आहे. ॲज युजल सेम कंडिशन आणि त्याचबरोबर जे काही कॉन्स्टंट आहे तशा पद्धतीने त्यांचे जे काही रिलेशन्स आहेत त्या ठिकाणी यूज आपण केलेला आहे. देन we can find or we can comparison between the magnetic field when a point is placed at a axis and equators. एखादा पॉइंट आहे, पॉइंट P, ते ॲक्सिसवर देखील प्लेस केलेला आहे, त्याचबरोबर इक्वेटर देखील वर प्लेस केलेला आहे आणि त्या दोघांमध्ये मॅग्नेटिक फील्ड कोणाचं जास्त असणार आहे या ठिकाणी आपण डिस्कस करणार आहे. देन दिस इज ऑल फॉर सेम. प्रत्येक गोष्टी या ठिकाणी काय आहेत, सेम आहेत, फक्त जे काय मॅग्नेटिक फील्ड ॲट ॲक्सिस आहे ते थोडंसं 2 इतका जास्त आहे. देन we write the equations, that is magnetic field at equatorials is equal to 2 into magnetic field at axis when the point is placed at axis. That is magnitude. We are just consider magnitude. When we are take the vector forms, will be use the signs. The negative signs will be direction different. When we are text axials, the directions of the magnetic field as well as the directions of at a point P will be same, but it is a perpendicular or in a different direction, we are take the negative signs. This is all about the bar magnets and magnetic and electric field of the bar magnets.